Obviously, this is a situation in which, because the denominator is one term, we can rewrite this function. If I had here, I'm going to erase it, don't write it. If I had here this, I could have not done what I'm going to do. But because there is only one term, we always separate it into fractions. If the numerator has 2 terms, then we will end up with 2 fractions. If the numerator has 10 terms, then we will end up with 10 fractions. So this is the integral from 4 to 9 from 2t over 4 the square root of t plus 5 over 4 the square root of t. Don't forget dt. This symbol, the integral symbol, does not exist without dt or dx or dy, whatever the function is in. Okay? So now, of course, I will simplify, and remember what happens here. I copy the base, the power of the top is 1, the power of the denominator is 1/2. So then all this will change into t to 1/2. And here I will keep the 5/4, but I will change 1 over the square root of t into t to negative 1/2 to make my life as easy as possible. So the integral from 4 to 9, so this is 2 over 4, which is 1/2, and t to 1/2, and then plus 5 over 4 t to negative 1/2. This algebraic manipulation is highly required, highly recommended, please. So now, because everything is so much easier at this point than it was initially, of course 1/2 goes outside, and I have t to power 1/2 plus 1, 3/2, everything divided by 3/2. And then plus 5/4 stays outside, and then t to negative 1/2 plus 1, which is 1/2, divided by that number, parentheses, from 4 to 9. Is everyone with me so far? Please stop me if you have questions. Anyone? Is this okay? Okay, I'm assuming that at least one of you is looking. I'm not sure. No one says anything. So then I have 1/2. I have to flip 2/3. I mean 3/2 into 2/3. T to 3/2. And then I have the 5/4, and I have to flip 2 over 1 times t to 1/2. The reason I'm flipping is because I'm dividing by a fraction. When I divide by a fraction, I have to multiply it by the multiplicative inverse. So 4 to 9. So now these two go away. So I have 1/3 in front, t to 3/2. Here I have 5/2, t to 1/2. Yes, I know I write big, but look at how many steps I needed to clean this up, to clean this up. So, okay, so finally I have to plug in 9, 1/3 times 3 to, I said 9. I don't want to simplify it yet. It is the square root of 9, which is 3, but I don't want to simplify it first yet. So it's 9 to 3/2, okay, and then plus 5/2, 9 to 1/2. So I plugged in 9, but now I have to subtract. And when I subtract, because that's the rule, that's fundamental theorem of calculus, I have to subtract when I plug in 4. So 1/3, 4 to 3/2, plus 5/2, 4 to 1/2. So you can distribute without putting parentheses, but if you forget to distribute to the second term, then the answer will be incorrect. Okay, so this is, you can put it in the calculator. I don't like to do everything with the calculator, but just in case. So I'm going to share my screen for a second. Here it is. Okay, so you can do this. It's the square root of 9, which is cubed. So the square root of 9 will be 3 cubed, which is 27. But let's say we don't know that. Just in case, put parentheses, 3 over 2, and you'll see we get 1027. Because it's the square root of 9, which is 3, and 3 squared will be 27. So then I have 1/3 in front. So 27 divided by 3 will be 9. Plus The square root of 9, let me stop sharing. The square root of 9 is 3. So 3 times 5 is 15 divided by 2. So this was 27 when we calculated, divided by 3 will be 9. And this is 5 over 2, but the square root of 9 is 3. So 3 times 5 is 15. So here, I have the same procedure. Is the square root of 4, which is 2. 2 to the third is 8. So minus 8 over 3. And this is the square root of 4, which is 2, which simplifies with the denominator, so minus 5. Okay. So a lot of steps because of these fractions. Otherwise, it wouldn't be that cumbersome. So 9 minus 5 is 4. And then plus the least common denominator will be 6. And I can include that in a minute. So 6, so I have 3 times 15 minus 2 times 8. So this is 4 plus 45 minus 16 divided by 6. So what is this? Is it 29? These are really ugly numbers. So 24 plus 29 divided by 6, and I'm getting 53 divided by 6. I'm checking my numbers, I get a 4. So yes, that's 15, and that's 45 and minus 16. So this is indeed 29. Yes, correct. Yes, okay. A lot of steps, a lot of work. Rita, is this okay?
Yeah, I had another question, but someone else can go if they have one.
So again, I want to thank everyone who is already in chapter 4, and I want to thank everybody who will be in chapter 4 by Wednesday, please. So 4 of you are in chapter 4, 4 of you are not in chapter 4. Please, please. Okay, I'm ready.
Professor Lee, exactly which section of chapter 4?
We finished 4.3, so that's the reason why I have these, right? If at any point in time you have any questions, once you see we are on page 402, in case you missed that, you will know exactly what we're doing, right? Yeah, that's why I'm trying to be as organized as possible. And I think I sent out an email, but maybe not. Maybe I forgot. It's possible at the end of the semester, everyone is tired. I'm sure you are very tired as well. Okay, any questions? Rita, let's go. Let's not waste time. Maybe they will ask after you ask the other question.
I'm going to share my screen.
Yes, please. Was the first problem clear?
Yeah, it was. It was just a simplification issue I was having.
Okay, very good. So this is I see 1 to e squared from 3x plus 6 over x. Is that correct?
Yep.
Okay, perfect. Okay, so in this situation, what I forgot to mention, and please always remember, we have to always check that this function is continuous on the interval 4, 9. This function is not continuous only when x is 0 or less than or equal, basically, right? But this is the interval is 4 to 9, so it has nothing to do with 0 and nothing to do with negative numbers. So this is okay. Function is continuous. The same thing here. This is always continuous, and this will not be continuous when x is 0. So everything is okay, it's safe. 0 is not between 1 and e squared. E squared is over 9, almost 9, right? It's 2.78 squared. So there is no discussion here. The function is continuous. I can apply fundamental theorem of calculus. Okay, so then, first thing is, I know it's 3x squared over 2. Why? Because when I differentiate this, I get x. The next one should be 6. Remember, 6 over x. 6 over x should be always considered like this. And this is, anyone remembers what function we differentiate to get 1 over x?
Is it the absolute value of ln x?
Yes, the natural log of the absolute value. Awesome. Okay, perfect. And this is from 1 to e squared. So I'm going to continue here. 3/2 in front. And I plug in e squared. E squared, but everything squared. Plus 6 natural log. These are positive numbers. The absolute value is not needed anymore. So I plug in e squared. Now I have to be careful because I have to subtract when I plug in 1. When I plug in 1, I get 3/2. When I plug in 1, anyone remembers natural log 1?
One.
Zero.
Yes. Yes. So, in case you forget, put in the calculator. So let me share the screen. In case we should remember this by now, but it happens. It's a lot of material, a lot of information. So you can always go back to y equals and just graph this function, or just plug in different values, right? When you graph the function, we graphed it several. Oh, I didn't. That's not the viewing window I wanted. Okay. The graphing calculator does not give a correct graph. The graph doesn't stop here. It goes all the way to negative infinity. It doesn't stop here. So careful. This is an illusion. They're trying to trick us. And as you see, it's right here. It crosses when x is 1, y is 0. Okay, perfect. So then I don't have anything else to subtract. Now here, we have to remember how to simplify this. Natural log e squared, the power goes in front as a factor. And now, anyone remembers how much is natural log e? That's it. So this piece equals 2. That will be multiplied by 6. So then I have 3/2. Copy the base, multiply the exponents. There is nothing I can do to this. 6 times 2 is 12 minus 3/2. So the least common denominator is 2, and this one will take a multiplication of 2. So this is 3e to the 4th plus 24 minus 3 plus 21.
I just had a quick question.
Yes?
I'm sorry if I missed it. For the second half, when you're subtracting the 3/2, the natural log, I know you said the natural log of 1 is 0. Oh, it's 0. Sorry, I didn't.
No worries, no worries. So since it's 0, 0 times 6 will still be 0.
Yes.
So for making sure there is no confusion, I will put minus 0 there. Good, very good. Other questions for me? Anything else?